S. Sterling. C. Curiosity. I. Innovation. E. Ethics. N. Nitty-gritty. C. Common sense. E. Exuberance. And that makes science. The science day at MGPS is an amalgamation of all this.
Rightly said by Albert Einstein. The important thing in life is to never stop questioning. And today, to fan this flame of eagerness, curiosity,
Recording in progress.
we at MGPS provide our blossoming scientists a platform to showcase their scientific fervor through experimental demonstrations, magic with science, enactments, mad twists, because we acknowledge the fact that science is simply common sense at its best. Today, I, Meghna,
And I, Vrinda Agrawal, on behalf of MGPS fraternity, feel privileged to welcome you all in the second day of Xpressions 2021, that is Science Day. We are glad to have with us honorable principals, judges, teachers, and enthusiastic participants. We would like to acknowledge the presence of our honorable judges, Mr. Sanket Vyas sir and Dr. Ambika Sharma ma'am. Sir, ma'am, we are glad and honored to have you among us. Also, I would like to thank esteemed dignitaries of ECMS for providing us a platform to showcase our potential. We once again welcome you all in today's spectacular event, Wonders of Optics.
optics. What does it exactly mean? I mean, this is a new term for me.
Let me explain. Optics is a branch of science that studies the behavior and properties of light. Don't worry, the rest will be unveiled by our participants.
Physics. Oh, that seems extremely boring.
I'm afraid I have a different perspective. Science is organized knowledge. It is the poetry of reality, based on facts and not fiction. So, Meghna, think like a proton and be positive about your science.
That was an eye opener, and it transformed my opinion. Science without religion is lame, and religion without science is blind. Today, the aspiring scientists are all eager to demonstrate and articulate their experiments and leave you all awestruck with their adroitness and subtle manner of presentation. This Science Day at MGPS will unfurl the seven colors of the spectrum and help the budding scientists project their acumen. So, are you all ready to witness the gala event?
Before starting the show, I would like to acquaint the participants with the rules of the event. Participants have to introduce themselves with their name and school code. Time limit for the experiment is 4 to 5 minutes. Judgment criteria will be knowledge of concept, utility in daily life, and presentation. Marks will be deduced if the participants exceed the time limit. In case of any network glitch at your end, we will call the next participant and come back to you later. Thus, I would request the other participants to be ready as well. And with that being said, we are all set to begin our competition.
So, our first participant is code number M03, and they're all set to surprise us with the wonders of science.
Am I audible and visible?
Yes.
Good morning, everyone. Today, our huge founder, code M03, will be presenting an experimental model based on one of the most common use of optics in our daily life, that is, eye defects and refraction. My model links the field of optics with the field of biology. So let's start. So let us talk about our eye. We all know that our eye has a convex crystalline lens, which converges the light rays falling on it on a screen-like structure known as the retina. The retina is penetrated by optic nerves, which takes this information to our brain. So here, I've tried to demonstrate an eyeball through my model, with this front part being the eye lens and this part being the retina. Also, I have placed a candle here, which will act as a light source on an object. and a lens holder to place the lenses for correction of eye defects. So, let me demonstrate before you the basic functioning of a human eye. Let me light the candle here. As you can see, I have lit a candle here, and as the light rays, they come from the candle, they pass through this eye lens and then get converged on this retina, and you can see how a focused image is formed. Now, let us start with myopia. Myopia or nearsightedness, it is caused due to, first, increase in the thickness of the eye lens, which increases the converging power of the eye lens, and second, elongation of eyeball or increase in the distance between retina and eye lens. So what happens in myopia is that the light rays, when they come from the object, they are converged by the eye lens, and they form an image somewhere in between our retina and eye lens. Also in myopia, the far point of a human eye, which for a normal eye is infinity, shifts and becomes closer to the eye lens than infinity. So let me adjust my model according to myopia, and here I am increasing the distance between the retina and the eye lens, and here I am shifting the candle a little bit backwards to represent the faraway object. Now, as you can see, a faint image is formed on the retina. Now, for its correction, I will be using a concave or a diverging lens. Why concave or a diverging lens? Because as the light rays come from this candle, they will fall on the concave lens, will get diverged, and when they pass through this eye lens, they will again be converged to form a focused image on the retina. So as I place it, I want you to focus again, and you see a focused image is formed again. The same can be represented through a chart here. Here you can see the far point of a myopic eye. Here you can see the normal far point infinity and the far point and the correction for myopia. Now, let us try and calculate the focal length of the concave lens used here. We will be using the lens formula 1 by v minus 1 by u equals to 1 by f, where u here will be minus infinity, v here will be minus x, where x is the shifted far point of myopic eye. Placing these values in our formula, we get power or 1 by f to be minus 1 by x. Hence, the power of this concave lens is minus 1 by x. Also, I want to state, though the major reason for all eye defects is the change in converging power, I will be focusing mainly on elongation and decrease in the size of eyeball and shifting of the object due to some practical restrictions in my model. Now, let us talk about hypermetropia or nearsightedness, farsightedness. Now, in hypermetropia, the main causes of hypermetropia are the thinning of the eye lens, which means the focal length of our eye lens, it increases, and the distance between our eye lens and retina, it decreases. So let me just show these changes. Here I have decreased the distance, and now I'm going to move the candle a little bit towards the setup to represent the near objects. As in hypermetropia, the near point of our eye changes from 25 centimeter and shifts somewhere beyond that. Now, as you can see here, the image formed is a bit fainter, but not as fainter as the one which is formed in our eye during hypermetropia due to some practical restrictions in my model. Now, let me use a convex or a converging lens. Why a convex lens? Well, it is because this lens will converge the light rays, and then when they pass through our eye, they will again be converged, and then they will form on the retina. So here I have introduced, and here you can see again a much more focused image is formed. The same can be represented through a chart here, and here you can see the near point of hypermetropic eye, normal near point, and the correction. Now, let us try and calculate its focal length. So using the lens formula 1 by v minus 1 by u equals to 1 by f, where v will be minus y, where y is the shifted near point, u minus 25 centimeter, where 25 centimeter is the normal near point. We get the focal length as y minus 25 upon 25y. So that was all about my model on myopia and hypermetropia. Thank you.
I would like to remind all the participants that time code number M04, please respond to the call. This is the final call for M04. Moving on to our next participant, code number M05.
Code number M05, the stage is all yours.
Am I visible and audible?
Please start.
Good morning, respected judges and the audience present here. I am here to demonstrate an experiment on TIR, that is total internal reflection. Total internal reflection can be defined as a phenomenon that occurs when a ray of light travels from an optically denser medium to an optically rarer medium at an angle greater than that of the critical angle. The working principle of TIR is that when a light ray travels from an optically denser medium to an optically rarer medium, it bends away from the normal, leading to the angle of refraction being greater than the angle of incidence. When the angle of refraction is 90 degrees, the refracted ray becomes parallel to the interface, and the corresponding angle of incidence is known as the critical angle. If the angle of incidence, as in this case, is greater than the critical angle, then the light ray gets reflected back internally, leading to the phenomena of total internal reflection. I'm going to demonstrate this with the help of a few experiments. I'm taking a green laser light and I'm placing a plane mirror over here. Now let's switch off the light. We can see that when a light ray is incident on the plane mirror, it bounces back into the same medium. We can see a green spot here. This phenomena is known as reflection. Now, I'm taking a beaker containing water and placing it on the stand. Now, let's see what happens when a light ray is incident from a rarer medium, that is air, to a denser medium, that is water, and again comes out into the rarer medium. Let's switch off the light. As you can see, the light ray gets refracted within the medium, and this phenomena is known as refraction. Now, let's keep changing the angle. It can be observed that at a particular angle that is greater than the critical angle, the light ray gets reflected back internally, leading to the phenomena of total internal reflection. Optical fiber is the practical application of total internal reflection. This is the optical fiber. It consists of a core and a cladding. Let's see this with the help of a diagram. So this is the diagram of the interior of an optical fiber. An optical fiber consists of a core, that is the inner part, and the cladding, that is the outer part. The refractive index of the core is higher than that of the cladding. When light rays directed at one end of the fiber at a suitable angle, it undergoes multiple total internal reflections throughout the fiber and finally comes out at the other end. Let's see this with the help of the optical fiber. Now let's switch on the light. I'm directing a light ray at one end of the fiber. You can see a zigzag line forming. It shows that the light ray undergoes multiple total internal reflections throughout the fiber and finally comes out at the other end. this with the help of an experiment. For this, I'm taking a plastic transparent bottle containing water and placing it on the stand. Now let's switch off the light. We can see that when a light ray is directed at one end of the fiber, it undergoes multiple total internal reflection throughout the medium. This is what happens in an optical fiber. Now, since the optical fibers can bend easily, as you can see, it is helpful in retrieving the internal body parts of the human body without any surgical process. Hence, it is used for endoscopy. Optical fibers are also used to transmit signals under seawater. You can see a diver holding a cable. Such a network of cables is placed underwater to transmit signals between distant places. Optical fibers are also used in airbags of cars. So, we understood the importance of the phenomena of total internal reflection in our day-to-day life, like in optical fibers. I hope that I was able to convey to you the diverse applications and utility of optical fibers and thus total internal reflection with the help of these experimental demonstrations. Thank you and have a nice day.
Wonderful performance. We are truly spellbound. This performance has set the bar pretty high.
Definitely. But this is just the beginning. Next in the queue, we have code number 06, who are certainly determined to astonish us with another experiment. Code number 06, please respond to the call.
Namaskar everyone, I am code M06 and today I am here to demonstrate a very simple experiment about a very wonderful phenomenon of diffraction of light. So, diffraction is basically bending of light across around the edges of the corners of wonders of optics.
Visualizing and understanding several ray diagrams on network is a very boring and time task, isn't it? So, this is mainly because we cannot actually observe the light traveling in air and therefore cannot trace its path. It would have been so easy to understand and draw these ray diagrams if we could actually observe them. So to help you out, we are here with an optical box. An optical box is an amazing combo of physics and chemistry, where you can actually observe several ray diagrams with great ease. Phenomena such as reflection, refraction, etc. can be easily understood. So let's have a look. In order to create this optical box, I have used a cardboard box.
Someone else is also speaking.
On the existing side of the box. To produce smoke inside the box, I have placed anything. Smoke, as we all know, is a colliding particle and can easily scatter the long wave and therefore make particles being visible. Before starting, I would like to ask you all one question. A person is not able to see nearby objects clearly and therefore uses specs to have a corrected vision. Can you identify the defect he is suffering from? Definitely that's hypermetropia. Its blur effect is because of the incoming light being focused behind instead of on the retina wall. But why is he using specs? Which type of lens is he using? I know you all are struggling with all such questions. So without much ado, let's get started.
Code number M06, please restart.
Okay, thank you. I am code M number M06 and I am standing here to demonstrate a very simple experiment about a very wonderful phenomenon of diffraction of light. So, diffraction is basically the bending of light around the edges or the corners of an obstacle or an aperture and its subsequent spreading into the geometrical shadow. So, for the experiment, we have a laser which will act as a light source, and for an obstacle, I have used a very thin bare strand which I have pasted on this CD. The light will pass through this hole, it will strike this CD and its projection will be visible on the wall. So now I am adjusting it so that the light can strike it and we can see its projection on the wall. So now for a better and a clearer vision of this projection, I will first turn off the lights and then I will focus my camera on the wall. So let's explore. So I think that you all can visit see this. So we can see that there is a very bright spot at the center. And there are alternative dark and bright fringes on either side of it. This happens mainly because of the wave nature of light. When the light gets refracted from the hair strand, it undergoes a phenomena known as interference. The bright bands you can see are due to the constructive interference of light, whereas when the light interferes destructively, this results in these dark spots. This phenomenon has various applications in everyday life. For example, it is due to diffraction that you can see various colors of a rainbow while viewing a CD from different angles. Diffraction is also present when you can see the sun appears red during sunset. And also you may have observed that light usually bends at the corners of the tones. Both of these phenomena are due to diffraction. This phenomenon is also used in X-ray diffraction, spectrometer, and holograms. So that was all with my presentation. Thank you.
Splendid. It is a real pleasure to see such innovative experiments.
Yes, it is. Next in the lineup, we have code number M12. The stage is all yours.
Code number M12, please respond to the call. Yes.
Unmute. Sir, you're muted.
Good morning. Good morning. I am code number M12 and my experimental demonstration is about the refraction of light. So I am going to take a glass of water and I am putting pencil on it. So watch it carefully. So when I put pencil on it, the pencil get bent. It does not bend actually, but because of our eyes get reflected, our eyes does not catch the actual position of pencil. Our eyes catch it badly. So reflection of light means the waves of light when travel from one medium to another. There are two mediums, the water and the air. When the light travels from the air to the water, the actual speed of light gets lower, and because the speed gets lower, it not actually get bent. It is in initial actual position. When we put it obliquely, we see it as a bend, because when the light get reflected from water, our eyes see it in a bent position. Thank you.
Thank you so much, participants. We appreciate your efforts.
Moving on with the event. The next participant, we have code number M13.
Code number M13, please respond. Moving on to the next participant, code number M.
Good morning,
Moving
everyone.
ahead,
This
code number M15.
Code number M14, are you ready with your presentation?
yes, I'm ready. Yes, sir. Morning, everyone. This is M14. Today, I'm doing an experiment related to wonder of optics. So let's get started. For this experiment, we need a box, lemon, and a laser light. Now we pour some water into the box and squeeze the lemon in it. Now after squeezing it, then we pass this laser light from this solution in such a way that the light passes from denser medium. You will see that the light comes up of the same medium. Light comes out from the same medium. And this is known as total internal reflection. Which means when light passes from same medium and comes out from the same medium. And this happens because of the critical angle. The critical angle, the angle made by the incident ray in the denser medium and the angle made by the reflected ray in the rarer medium is 90 to the surface. Then this forms critical angle, and this phenomenon is known as total internal reflection. The utility of the total internal reflection is optical fiber, which were used by surgeons to look inside the body of a patient. It is also help in zooming and also in the formation of mirage. We also use this total internal reflection as if we want the image in the same medium. Thank you.
Excuse me, M14 student. Could you take your camera on, sir? Yeah, am I audible to you?
Yes, sir.
Okay. So could you tell me about what is the basic factors on which critical angle depends?
Sir, the basic necessary conditions on which the critical angle based is that the light should move from denser to rarer medium, and the incident ray should be on, and the incident angle should be greater than the critical angle.
Right. It is only the necessary condition you are telling me. I am asking about on what factor does the critical angle depend? Like if you want to calculate it mathematically, there will be some parameters on which it will be like depending on. Do you know that?
Sorry, sir, I don't know that.
Okay. Have you heard about refractive index, bache?
Yes, sir.
So you are telling that it will be moving from denser to rarer, right?
Yes, sir.
So that is the change in refractive index. Is it correct?
Yes, sir.
So the change in refractive index is the parameter with which the critical angle would be affected, right?
Okay, sir.
Okay. Okay. Good luck, bacha.
Simply spectacular.
Get your hopes up for the next participant. We have code number M15.
Code number M15, please respond to the call.
Yes, I'm here. Am I audible? Am I audible?
Yes, bacha, you are audible. You can continue.
Thank you, sir. I'm Divyanshi Chandani and my school code is M15. Good morning, everyone. There's a very natural question which pops up in everybody's mind. What is light and what is the nature of the light? In fact, nature of light has always been a subject of inquiry from antiquity. In 17th century, Descartes proposed corpuscular theory, according to which light has particle nature. It was also stated by Sir Isaac Newton. A very young scientist in that very same era, Christian Huygens, opposed the former theory and proposed that light had a wave nature. He was successful in explaining phenomena like interference, diffraction, polarization, etc., but had a disadvantage because he proposed that light is a mechanical wave. Now, there's a thing to wonder. If light is a mechanical wave, then how would sunlight travel from space to the Earth atmosphere? Christian Huygens answered that let's consider that universe is a massless without density and a colorless matter, and it has no density. Now, near that time, Maxwell came forward and proposed his formulation for electromagnetism, and he stated that light is indeed an electromagnetic wave. Now, finally, in 1905, the dilemma that whether light is a particle nature or has a wave nature was finally brought to an end when it was proposed that it has dual nature. Now, isn't it a wonder that it took so much time and effort just to answer one single question? Now, let me demonstrate some fundamental experiments to see some wonder of optics and to draw some outstanding results from them. Now, we all know about the lateral inversion. Lateral inversion is the apparent reversal of left and right. And now I have this arrow pointing towards that direction. And now here you can see that is directing towards that side. Now here water acts as the lens and causes lateral inversion. Now there's another experiment where I'm taking this paintbrush with me and I'm dipping it into water, and we can see it's straight, right? But after dipping in here, we can see this, it's bending. How is it possible? Because here, the point at the end of the toothbrush, there are many lights coming out from the water. And some of the lights, when coming from water to the air, bend. And due to which we see it bending. It's an illusion, which is caused by persistence of vision. Now, there's a very beautiful experiment. Now, from lens formula, we know that mu2 upon mu1 minus 1, 1 by f is equals to mu2 upon mu1 minus 1 into 1 upon r1 minus 1 upon r2, where mu2 and mu1 are the refractive index. Now, what if mu2 and mu1 become equal? Then 1 by f will be equals to 0 and f will be infinite. That means light will intersect at infinite distance and the object will almost become disappear. Let me show you how. I'm taking sunflower oil and I'm taking a shot glass in a jar and putting some sunflower oil in it. Now we can definitely see, we can see the shot glass right now. Now filling it to it, we can see it's almost disappearing. It's a magic, right? Indeed, science is full of wonders, right? Now, there's one more exciting phenomenon we could say, TIR, total internal refraction. The total internal refraction says it occurs when light moves from denser to the rarer medium and it bends away from the normal. It is caused when incident angle is greater than the critical angle. Now I have a laser beam with me. I have a bottle. Now I'm passing this laser light from the bottle and it's passing straight away from it. Now when I pass through the hole, we could see that it faces a TIR, because when it comes from water to the air, it faces TIR in bends because the incident angle is greater than the incident angle. And you can see the watercolor is green now. Now, there's a very astonishing statement in wave optics that light plus light is not always light. What does it mean? It means that I'm taking a light bulb over here. I'm taking a camera.
Code number 15. You have exceeded the time limit.
Now, it's a final experiment. We can see that it's a light bulb, and from the camera it's visible and it's just a white light, right? But when I move towards it, we can see some black and dark pattern on it. It's because of interference. Interference is a phenomena where two waves superpose to form a resultant wave. And according to superposition principle, when there's a constructive addition of two waves, it then forms a light patch. And when it's a destructive, it forms a dark patch. And we can see light and dark patches appearing on my phone screen. Thank you so much.
Could I ask you one thing, Bache?
Sure, sir.
We have used laser light in the experiment of TIR. Am I audible to you?
Yes, sir.
Could you tell me what is the difference between is laser light a coherent source of light?
Pardon, sir?
Is laser a coherent source of light?
No, sir.
Okay. Do you know the meaning of coherent source? Have you heard about it?
Yes, sir.
What is the basic definition of coherent source?
Any two sources which sustain interference.
I suppose you are missing something. Co means when you attach the word coherent, that means it should have a relative phase difference. Okay, actually you are having some time limit exceeded. Okay. Please. Okay. Good day, Bacha. We'll talk later. Okay.
Thank you so much, sir.
Another marvelous experiment. These concepts seem so tough in theory, but seeing the practicals is a different feeling altogether.
Yes, it is. Another participant to raise the curtain is code number M16.
Code number M16, please respond to the call. This is the final call for code M16.
Am I audible?
Yes.
Light is a wonderful thing. The study of light, known as optics, is an important research area in modern physics. A very good afternoon, a very good morning, judges, teachers, and dear friends. Today, I, Arsha Satyarthi, code number 16, will be performing a few live mind-blowing experiments on the topic Wonder of Optics. Experiment number 1, disappearing paper. Here, it's clearly visible that the paper under the glass, which is empty, is visible, whereas the paper, which is under the glass filled with water, is not. Now, to understand this, the tumbler acts as a thin wall of glass, and therefore the light rays hardly suffer any deflection and passes straight through the camera. Whereas when the tumbler is filled with water, the light rays suffer deflection and the paper disappears. Now, let me tell you beforehand, this next experiment is not magic, but completely science. So moving on to experiment number 2, vanishing tumbler. I'm sure all of you have seen how the glass magically disappears as soon as it is dipped in oil, whereas the other glass is still visible. Now, in this magical demo of science, the oil and the glass have the same refractive index, and hence that means that light does not change direction when it passes through the beaker and back. And since the beaker can't bend any light, we can't see it. Moving on to the third experiment, which is inverted arrow. The arrow changes direction. Even though I am pretty sure all of you already know the reason, let me still explain it, considering I'll be getting marks for this. The glass filled with water acts as a cylindrical lens. So when the image is formed by the arrow, it is inverted. The arrow is kept between the points F1 and F2. The image formed is exactly the same as the image formed by a convex lens. Now, for the last experiment, let me warn you, this experiment is absolutely exhilarating. Moving on to colored world. So I have this dark blue bottle with me. Maybe please switch off the lights. It's visible that when the lights turn to red, the bottle instead of dark blue appears black. Also, when the light is green, the bottle appears somewhat black, but still giving a hint of blue. Similarly, I have this yellow notebook with me. Now, when the light is green, it still appears yellow. And when the light is red, I'm sure you can see that it's yellow, but red is more dominating. Now, to understand this, it's no longer a secret that white light is made up of 7 colors. We usually remember this using the acronym VIBPure. So when we all know that the yellow color is made up of green and red. So when red light strikes on a yellow surface, it reflects green and red, which makes up its natural color yellow, but with red dominating. Similarly, when a green light strikes on a yellow surface, it again makes up green and red, with yellow as resulting and green as dominating. That's all, everyone. I hope you enjoyed watching these as much as I enjoyed presenting them to you. Thank you and have a wonderful day.
Wonderful. And 16 participants.
This experiment was truly admirable. I am glad to be the one witnessing it. Vrinda, I have a mind-boggling question for you. Ready?
Not really, but seems like I don't have a choice.
Of course you don't have. So the question is, I am a god, planet, and I can measure heat. What am I?
Oh, I know, it's Mercury.
Absolutely correct. You are becoming incredible in my company, of course.
You took the credits again.
Our arguments are endless, so keeping them aside, let's continue with the show. Now, Mr. Ankit Vyas, to share his views and boost the morale of all the participants. Please, sir.
Good morning, everybody. I would like to congratulate for every participant to participate. Is my video visible to all of you? I would like to congratulate every participant to share their views with a wonderful experimentation they are performing here and the demonstration they have already yielded us with a good explanation. Every student here is like getting motivated with all the demonstrations they are showing by themselves or by the other students also. It is highly recommendable by the teachers to like show experimental videos to the students. But here I'm seeing that all the colleagues like staffs and all those students who are participating here are extremely showing beautiful experimentation, and they are really beautiful enough So it would be my pleasure to host this up, and I would always be thankful for MGPS to let me into the judge criteria, so that it could be easily and wonderfully seen that wonder of optics can lead to imagination, creativity, and explanation with a very good concept demonstrated by our students. Thanks a lot. So I suppose that will be all from my side, and the motivation from my side would be keep doing and keep learning. Please, thank you.
Thank you, sir. Our next participant is code number M20.
Code number M20, are you there? Please respond to the call. I repeat, code number M20.
Ma'am, I have a network issue. Can I just do in 5 minutes?
Okay. So moving on to the next code, M21. The floor is all yours.
A very pleasant morning to one and all present here. Today, I, code number M21, would like to demonstrate an experiment in front of you all on the theme Wonders of Optics. Visualizing and understanding several ray diagrams drawn in our book is a very difficult and boring task, isn't it? This is mainly because we cannot actually observe the light traveling in air and therefore cannot trace its path. It would have been so easy to understand and draw these ray diagrams if we could actually observe them. So to help you out, we are here with an optical box. An optical box is an amazing combo of physics and chemistry, where we can actually observe several ray diagrams with great ease. Phenomena such as reflection, refraction, etc. can be easily understood. So let's get started. In order to create this optical box, I have used a cardboard box and have made two windows on the adjacent side of the box. In order to produce smoke inside the box, I have used incense stick and have placed them inside the box. Smoke, as we all know, is a colloidal particle and can easily scatter the long wavelength of red light and ultimately makes the path of laser beam visible. Before starting, I would like to ask you all one question. A person is not able to see nearby objects clearly and therefore uses specs to have a corrected vision. Can you identify the defect he is suffering from? Definitely, that's hypermetropia. The blur effect is because of the incoming light being focused behind the retina instead of on the retina wall. And therefore, the person is not able to see nearby objects clearly. But why is he using specs? Which kind of lens is he using? I know you all are struggling with all such questions. So without much ado, let's get started. When a laser beam passes through a convex lens, it converges. That is, the convex lens increases the refraction and decreases the focal length of the incoming light so that the image is focused on the retina wall. And therefore, the person is able to see nearby objects clearly. In fact, Galileo was one of the scientists of the early days to use a telescope with a convex lens in order to observe moon and other alternative objects in the night sky. So, moving on, you know what happened yesterday? I went to an eye doctor as I was not able to see distant objects clearly, and he advised me to use concave lens. Do you know why he asked me to do so? Let's see. When a laser beam passes through a concave lens, it diverges. That is, the concave lens decreases the refraction and therefore increase the focal length of the incoming light so that the image is focused on the retina wall.
and therefore the person is able to see distant objects very clearly. Apart from this, concave lens has a number of applications in daily life. It is used as a spy hole in the door so that we can see the visitors from a small opening, and is also used in flashlights so as to diverge the light. Now, let's trace the path of light when it passed through a prism. Can you see two phenomena simultaneously? Reflection as well as refraction. In fact, a prism is used in binoculars to produce erect images so that it can be made suitable for the human eye, and also it reduces the optical path of light so that the binoculars can be made small. Now I hope instead of cramming these ray diagrams, you will definitely enjoy them while actually doing them with the help of this optical box. That was what all I wanted to share with you. Thank you for being such a wonderful audience.
Well, well, well. Dynamic is the word I would use to describe this one.
Absolutely. Now, I take the privilege of inviting our judge, Dr. Ambika Sharma ma'am, to enlighten us with her pearls of wisdom. Please, ma'am.
Dr. Ambika Sharma, ma'am.
Video on karo. Hello, am I audible now?
Yes, ma'am.
Okay, good morning all. I must congratulate all the participants for displaying their experiments of optics in a very simpler way and in a very innovative way. They have opened the doors of the curiosity and the creativity.
So that we can see your presence virtually.
Yeah. Just wait for a while. There's some problem in my video.
No worries, ma'am.
Video on karo. Can we have
I think there is some network glitch at Ambika ma'am's end. Moving on with our next participant, code number M22.
Good morning.
I repeat, code number M22. The floor is open for you.
Good morning, respected judges and my fellow participants. The theme of today's competition is the wonders of optics, under which I have chosen to present the Infiniti Mirror. This is the live demonstration of my Infiniti Mirror. These are the materials required for the Infiniti Mirror, and this is my Infiniti Mirror. At first glance, it just looks like a regular clear. So can I restart it?
क्या हो गया?
Is my voice clear now?
ऊपर कोई आ तो
Am I audible?
Yes, 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 yes.
Now is the voice clear? So I'm restarting it, okay? The topic of today's competition is the wonders of optics, under which I have chosen to present the Infiniti Mirror. This is the live demonstration of my Infiniti Mirror. These are the materials required for the Infiniti Mirror. And this is the Infiniti Mirror which I have made. At first glance, it just looks like a regular mirror. But when we turn it on, it just looks like a deep tunnel lined with lights. So now I would like to elaborate my topic through a PPT. The very first question that comes to mind is, what is an Infiniti Mirror? The Infiniti Mirror is a configuration of two or more mirrors placed parallelly, thus creating a series of reflections. These are some finest examples of Infiniti Mirror. Before understanding how does an Infiniti Mirror works, let's build one. We would need the following material: plate mirror, cardboard box, one-way mirror, LED, adhesive, battery or power supply. Now, the first step to build the Infiniti Mirror is to design the layout. We need to ensure that the shape and dimensions of the plane mirror and the one-way mirror are same as that of the cardboard box. If the cardboard box has a circular base, then both the mirrors must be circular. Moreover, the mirrors must not be too smaller as compared to the box. Now, stick the fully reflective mirror to the bottom of the box. For the next step, if you are using strip LEDs as I have, you can directly stick them to the inside surface of the box at an appropriate distance from the bottom. On the other hand, if you are using a string of LED bulbs, make hole of the size of individual bulb and fix them in the holes such that the bulb face the center of the box. Now, draw a rectangle on the lid of the box. Make sure its dimensions are slightly smaller than the one-way mirror and remove this rectangle from the lid. Now, stick the fully one-way mirror to the inside surface of the lid such that its reflective surface faces the plane mirror. Now, ensure that every item is positioned correctly and secured with enough adhesive. Connect the LEDs to the power source and switch it on. The Infiniti Mirror is now ready. We can use different kinds of LED and can arrange them in different patterns to make visually stimulating Infiniti Mirrors. So, how does the Infiniti Mirror work? The underlying concept of Infiniti Mirror is indefinite reflection. It occurs when we place a light source between two parallelly arranged reflective surfaces. The plane mirror is coated with a layer of paint over the reflective film, such that no light can pass through it, as shown in grey. When we turn on the light source placed between the two mirrors, the light starts to reflect back and forth between the reflective surfaces indefinitely. Since the one-way mirror is not coated with a layer of paint as shown in blue, it allows some of the light to escape. This light is visible to the observer standing outside the arrangement. Each time the light escapes the Infiniti Mirror, it gets dimmer inside and creates an excellent tunnel effect. Now, we have the uses of Infiniti Mirror: optical illusions, elevators, houses of mirrors, designer furnitures, and walls. To sum up, my project is a tiny but dazzling speck on this vast realm of science. The most impressive fact about it is that it is based on the simple concept of indefinite reflection, yet it could generate marvelous effects. Thank you.
Excuse me, ma'am. Excuse me, ma'am.
Yes.
Sorry for inconvenience caused. Actually, I was facing the network too. So, can I show my presentation now? I'm code M20.
Oh, yes.
Okay.
Code M20, are you there?
Yes, ma'am.
Please start your video.
Am I audible? Okay.
Yes, you are
Good
audible.
morning. And today I'll be demonstrating experiments to show the wonders of light. So I'll be showing a series of 4 experiments.
I request the participant to switch on video. M20.
So,
I repeat again, code M20, please switch on your video.
This is code M20.
Yeah.
Am I audible?
You are audible.
Am I
Please
audible?
switch on your video.
Oh. My video is on.
You are visible.
Okay, thank you. Greetings to one and all. This is code M20. So projectors have evolved drastically over a period of time. Today we couldn't have imagined cinema halls without projectors. So if you've ever gone to a cinema hall and ever noticed that there is a ray of light coming from behind which is projecting the entire movie on the big screen. So do you wonder what is it? Do you want to know the concept behind it? Right. So today I'm going to present my model here. This is a homemade mini projector. It's the concept of optics. So I have made it using cardboard box and 2 lenses. These lenses are nothing but the lenses which are used in magnifying glasses, that is convex lenses. So convex lenses converge the rays of light. So the image formed by the convex lens can be received on the screen as it is a real image formed as a result of the collection of the refracted rays. A convex lens is thicker in middle and thinner at the edges. So it's used in cameras, focus sunlights, overhead projectors, microscopes, simple telescope, and of course magnifying glasses. And it can also be used for the correction of problem in the long side. So in terms of this projector, let me explain the entire process to you. Most projectors create an image by light transparent lens. That is this. So I have used 2 lenses. I have already told you. Source of light, that is a video on my mobile screen, and as to get the best effect. And I would be placing it inside this box with the screen facing towards the lens. And offer bills if it's done. So the video needs to be upside down. That if the final output we get would be inverted, actually inverted. So now I'll be showing you
Code number M20. There's a network glitch at your end, so we will come back to you later. Now, Dr. Ambika ma'am has joined us again. So now I would like her to enlighten us with her pearls of wisdom. Please, ma'am.
Good morning, all. It's a great privilege for me to judge all young innovators and the scientists of the future. I thank MGPS to give me an opportunity for this precious moment. And I must congratulate all the participants for displaying the very difficult and a very complex topic of optics in a very simple and very innovative way. They have opened the doors of curiosity and the creativity from the old today to the new world of tomorrow. I must congratulate again for all participants for their future endeavors. Thank you. That's all from my side.
Thank you so much, ma'am. Your pleasing words will always echo in our hearts. Let's see who is the another one to ignite the fire. Code number M23, the stage is all yours.
Am I visible?
Yes.
Okay. Good morning, everyone. Today, Ansh Thulia, code M23, is here to demonstrate a model to represent refraction, dispersion, and reflection of light. We all know that light travels in a straight line. The speed of light is maximum in vacuum, but in mediums, it slows down a bit. The reason is, in a medium, there are atoms all around. When light hits these atoms, it gets absorbed and is re-emitted to pass through. Because of this absorption and re-emittance, there is a time difference, which leads that the time that the light goes slowly. Light also depends on the material in which it is traveling. For a material which is optically denser, it appears that light travels slowly, whereas which is optically rarer, it appears that light travels faster in it. So the light speed is directly proportional to the optical density of the material. When light hits the interface of two materials, it bends by an angle. But once it has bended, it goes in straight line in that material because light has the tendency to take the path which has the least time between any 2 points. But today, I'm going to show you a material in which light travels in a curved path. Let's start this. So here we have a box which is filled with the material and I have a laser lamp. When I point laser inside this material, we can see that towards the end, light bends. Here we can see that light is bending towards the end. Reality, refraction and reflection both occurs. Through the experiment, we can show you this as well. See, you may be seeing that there is a light on my thumb. That is a light that is getting reflected from the container. And also light is entering the container as well. So we can prove this that light also gets reflected and refracted to the material. In 1812, Scottish scientist Brewster said that if the angle between the reflected and the refracted beam is 90 degrees, then this angle is called polarizing angle. The reflected light is plane polarized light, whereas the refracted light is partially polarized. In the real life, we can see this phenomena in mirage. One second, I'm sharing a screen. This is the image of mirage. Mirages occur on hot days when the air above the road gets heated up. Because the air gets heated, it becomes optically rarer, whereas the air in above reaches of atmosphere is optically denser. When light from above reaches of atmosphere reaches the bottom, it gets bends upwards and becomes parallel to uh, the road. And when somebody from the road comes towards it, the rays enters his eyes and appears that there is sky in the road. This is the phenomena of a mirage. Light enters from above the sky, and because there is hot air, it bends. And this phenomena is called total internal reflection. It occurs when light from denser medium moves into rarer medium and changes its path. So through this demonstration, we can see that all the three phenomena, dispersion of light, reflection and refraction, is shown. Thank you. I've done. Completed.
Okay. We appreciate your efforts, participants. The next in the queue, we have code number M24. Let's see what they have in the bag for us.
Code number M24. Please respond to the comment. Okay.
Good morning and namaskar everyone. I am Mohit Chaudhary, code M24, and I will be presenting some amazing optical illusions which will blow your mind. So here we go. First, we will see the experiment. Then we will discuss about its working and the use in everyday life. So here in this first optical illusion, I have two arrows pointing in the same direction and an empty glass I have placed in front of them. Now, with the help of an optical illusion, I will change the direction of one of the arrow. For this, I will add water in the glass. And here you can see the direction of the low arrow, which was earlier in right, pointing towards right, is now pointing in the left direction. This was the first illusion. Now let's move to the second illusion. So here is the optical illusion number 2, the equal arcs. Here I have two arcs, arc A and arc B. It is clearly visible that arc A is smaller than B, but when I reverse them, arc B becomes smaller than A, but actually they both are equal. Let's see the third one. So here is the third optical illusion, the floating cube. Here, can you make a 3D object float in air? Maybe not, but here with the help of an optical illusion, I am making this colorful cube float over my hand. But it's actually a piece of paper attached by a straw. This was the third optical illusion. Now let's see the fourth one. The disappearing dots. Here in this image, there are 16 black dots, and what you have to do is focus on any one of these dots and try to see the other black dots simultaneously. But due to the false perception, you won't be able to see all the black dots at once. Now let's move to the next illusion. So here is the last optical illusion, the size confusion. Here is a 3D figure, and I have placed two straws, one over this edge and other here. It is visible by geometry that this straw is bigger than the second one, but when I bring them closer, they both become equal in size. So now let's discuss how this was happening. So the optical illusion happens when our brain and the eye try to speak in the same language, in a simple language, but the perception gets a bit mixed up. The information gathered by the eye is processed by the brain, creating a perception that in reality does not match the true image. It also gives us insight about how the vision and the brain works. So the optical illusion as well as multi-sensory illusion involving visual perception can also be used in monitoring and rehabilitation of some psychological disorder. Hope you enjoyed it.
Excuse me, ma'am.
Yes.
Ma'am, I'm M20. Can I now show?
We will come back to you later on.
Okay, ma'am.
So the experiment was absolutely phenomenal. I am stunned. Definitely astounding. The next in the queue, we have code number M25. The stage is all yours.
Good morning, everyone. This is M25, and today I would be demonstrating experiments to show wonders of light. So I'll be showing a series of 4 experiments. The first of them will be about interference. So interference is basically when 2 covalent light waves superpose each other and then get redistributed. So now I'll be showing you my experiment. This is my camera, and this is the source of light. As you can see on the screen, there are dark and bright fringes. These are due to a result of interference. The dark fringes are known as destructive interference, and the light fringes, bright fringes, are known as constructive interference. The second experiment that I would be showing you guys is about diffraction of light. So over here, full of water. So as I move the arrow towards my left, you guys can see that it is actually moving towards right. And the fourth experiment that I would like to show you is with this pencil. It shows that the bending of light actually takes place. This is a straight pencil which is not broken or curved. So when I put this pencil into this beaker of water, you guys can see that it actually appears curved, whereas in action it's straight. So this is all an illusion which takes place. No, thank you.
It was beyond the line of excellence. I just loved it. Now, we would like to get back to code number M04. Code number M04, I hope you are back. Code number N04, are you there? Please respond. Code number M20.
Yes, ma'am.
Code number M20, are you there with us?
Yes, ma'am.
Yes.
Greetings to one and all. This is code number M20. So, projectors have evolved drastically over the period of time. Today, we couldn't have imagined cinema halls without projectors. So, if you've ever went to the cinema hall and when they darken the lights, have you ever noticed a ray of light coming from behind, which is projecting the entire project on the big screen? Well, this is no magic, but there is a concept of science behind this, the concept of optics. So, this is a mini homemade projector which I have made using cardboard box and lenses. These lenses are nothing but the lenses which are used in magnifying glasses, that is convex lenses. Convex lenses converge the rays of light. The image formed by the convex lens can be received on the screen as it is a real image formed as a result of collection of the refracted rays. A convex lens is thicker in middle and thinner at the edges. Used in cameras, focus sunlights, overhead projectors, microscopes, simple telescopes, magnifying glasses, etc. It is also used for correction of the problem in long sight. So in terms of this projector, let me explain the entire process to you. Most projectors create an image by shining a light through a small transparent lens. So here I have used two lenses. Now I would be placing a source of light, that is a video being played on my mobile screen. I would be keeping the mobile on full brightness so as to get the best effect, and I would be placing the box with the mobile screen facing towards the lens. This experiment would offer best results if done in a dark place. And also the video needs to be put upside down and laterally inverted, as we would obtain an inverted and a laterally inverted image on the screen. So now I'll be covering this so that light cannot pass through this and we get the best results. Now I'll be switching off the light. Okay. Now I'll play the video inside this, cover this, and now here you can see the video being played right here. I can adjust the clarity of the video by bringing the magnifying glass closer or farther. So as you can see, this is the video being played right here. We can obtain this video on the screen as a result because it's a real image. A real image is being produced by this convex lens. So I hope you can see this image being played right here. Yeah. Right, so now this brings us to the properties of images formed by a convex lens. A double convex lenses or converging lenses rays from the object by refracting the rays twice. At the front side of the lens, the rays are bent toward the normal because the glass is a denser medium than the air. And at the back side of the lens, the rays are bent away from the normal as the rays pass into the less dense medium of the air. This double bending causes the rays to converge at a focal point behind the lens so that a sharper image can be seen on photograph as seen in this diagram. So now, be stress-free because you don't have to strain your eyes by watching the video in your phone. Rather, you can make this mini projector at home and enjoy the view from the projector. So thank you so much.
Simply spectacular. Now let's invite our next participant, M26, on stage. Code number M26.
Am I audible?
Yes, you are audible.
Good morning, everyone, respected judges and all. I am representing M26. Today, I will explain you the concept of periscope. Have you ever wondered to see that Z-like structure in which one can see through the other side? A periscope is an instrument for observation over, around, or through an object, obstacle, or condition that prevents direct line of sight observation from an observer current position. In its simplest form, it consists of an outer case with mirrors at each end and set parallel to each other at a set of 45 degrees. A very common example of periscope, we can say that a submarine, when submerged at a relatively shallow depth to search visually for nearby targets and threats on the surface of the water and in the air. Now, I have made a periscope, as you can see that on your screen. It is made from the waste material in which we can see that from this side and from that side we can see the object very clearly. Now, this is because there are two sets of mirror. This one is the upper set of the mirror. This one is the downer set of the mirror. The first one and the second one. I won't make it any complex. I will make you as simple as I can. There are two sets of mirror. One is here, one is here. Both are at the angle of 45 degree, so that when the light falls on the object and reflects towards the upper mirror, it again gets reflected towards the down mirror, and then it again gets reflected and is visible through our eyes. Now, I will tell you that how the images form. We know that these both are plane mirrors, and we also know that when we see an image on a plane mirror, it is literally inversed. Now, as there are two mirrors, one is up and one is down. Firstly, as it is lateral inversed, it cancel out each other because there are two. Firstly, it is lateral inversed, and then it is cancel out to see. Then we can see that an erect image. It is virtual, erect, and without any lateral invasion. And we can also simply see it by making some light, and we can see that you can see that the light is coming from the camera, and this is only because there are two sets of camera that make it doesn't a literal inversion. I hope you like it. Thank you.
Well done, participants. We appreciate your effort.
Now, our next participant for the day is code number M29. I repeat, code number M29.
Good morning to you all. I, Anirudh Agarwal, code M29, is thankful to all for providing me the opportunity to perform. The basic thing about light, or everything we see about this world, is because some light from a source reflects on an object, bends the light, like converging lens converges a light and diverging lens diverges lens. So using these two, we can bend a light around an object, so to create an invisibility illusion. So I have done the same by using some lenses. So let me show you my model. This is my model I have made. These are four converging lenses. These lenses bend light as shown in the following data. Light enters from this lens, it converges, and then this converging lens right there makes the light back parallel. But because the light has inverted vertically here, we need to add one more lens here so that the light becomes again vertically inverted, so we can see the same vertical orientation. Now, if we put an object right there, so as you can see, I put an object right there, we can see it properly. But then I put the object right over the focus on the edge of the lens. The object is not visible through the lens. This happens because this lens bends the light beneath the object, and then the ray goes here, which shows as the background. This simple trick can be used to create invisibility, just like this. Very easy. This thing can be used in creating illusions for magicians or circus to entertain people. Thank you for. Thank you one and all for lending me your ears. I hope you are amazed by my presentation. Thank you.
A superlative soft skill. Indeed. Let's see what the next participant have. Let's see what the next participant have got for us. Code number M32. The stage is all yours.
Good morning, everyone. I, code M32 from Paramount Vidyashan School. I am here to show you one chemistry experiment. So, my topic is testing of carbon dioxide gas. So, before starting the experiment, I would like to tell you all the pretests required for this experiment. First is hydrochloric acid, pure. Second is lime water. Third is calcium carbonate. Fourth is 2 test tubes with the test tube holder. Sixth is funnel. Seventh is the delivery tube, spoon. And eighth is masks and gloves for protection, which I am already wearing. So, let's start the experiment. First, I am going to take the funnel and put it into the first test tube and add lime water into the first test tube. This much will be enough. Now I have to take the funnel and put it into the second test tube. And now to add hydrochloric acid into the second test tube. Put the funnel back. And now I have to add calcium carbonate into the second test tube containing hydrochloric acid. But before adding the calcium carbonate into the second test tube, I would like to tell you the reaction which will happen into the second test tube. The reaction will be carbonate plus acid is equals to carbon dioxide gas plus water plus salt. The reaction is written over here also. So let me add calcium carbonate into the second test tube. Now let me add it. And now I have to take the delivery tube and put the rubber stopper into the second test tube and insert it into the first test tube. As you can see, these bubbles are of carbon dioxide gas. And now the carbon dioxide gas is dissolving into the first test tube containing lime water. And now, as you can see, the lime water color has changed to the white color. So the reaction is completed over here, and I've put both the test tube back and take out the funnel. So the final observation is the lime water turns to milky color, to the white color. This reaction and this observation is due to the reaction between lime water and carbon dioxide gas, which turns the lime water to milky. So this was by the carbon dioxide gas. So this method is helpful in daily uses, like the gas which we exhale is also carbon dioxide gas. So we can identify which gas we exhale by this method. And the gas used in all the sodas and the cold drinks are also carbon dioxide gas. When we open the caps of this, the sound has come, and the gas which is exhaled by this is also carbon dioxide gas. So by this method, we can identify that the gas which is coming out from the soda water and all the cold drinks are also carbon dioxide gas. So this was my experiment and explanation. I hope you liked it. Thank you and have a nice day.
This is truly admirable. I'm glad to be one witnessing this. I remind the participants not to disclose their school names. Let's welcome another magnificent participant, code number M34. The stage is all yours. Code number M34, are you there?
Yes, I'm here. Am I visible? Am I visible?
Yes, you are.
Thank you. Good morning. This is M34 here. So today I will be explaining diffraction and interference. Diffraction is the process by which a beam of light or other system of waves spread out as a result of passing through a narrow aperture or obstacle. So in this experiment, when I put an obstacle or my hand in the path of the beam of light, either I obtain a shadow in the back or the light is stopped by my hand. But what happens in case of a narrow slit? Let's see. As you can see, this doesn't happen in case of a narrow slit. This is because the slit is physically the approximate size of the light's wavelength. So, what is interference? Interference is the combination of two waveforms which form a resultant wave in which the displacement is either reinforced or cancelled. When a monochromatic light is passed through double slits, I obtain a pattern of dark and bright fringes. These interference patterns are observed because of the superposition of overlapping waveforms coming from two different coherent sources. So in this experiment, as you observed, the intensity of light is high at the center. As you can see, the intensity of light is high at the center, but as we move away from the center, the intensity decreases. This is because at the center, the waveforms combine together and they give constructive interference. So we obtain the maxima. But as we move away from the center, the waveforms combine together and they give destructive interference. So the light is not that bright. Now coming to the differences between interference and diffraction. Interference happens because of the superposition of overlapping waveforms, interference happens because of the superposition of overlapping waveforms coming from two different coherent sources, while diffraction happens because of the superposition of secondary wavelets coming from different parts of wavefront. In interference, the fringe width is constant, while in diffraction, the fringe width keeps changing. And in interference, the intensity of number of bright fringes is constant, while in diffraction, the intensity is higher at the center, but as we move away from the center, the intensity decreases. Interference happens because of the superposition of two different waveforms combining together. So, the separation between the slits should be as small as possible. In diffraction, different parts of the same beam of light interfere with each other to give diffraction patterns. So, you can simply say that a beam would show diffraction from the interference of individual rays. Now, coming to daily life uses. Daily life uses of diffraction are a CD reflecting rainbow colors, sun appearing red at the time of sunset, bending of light at the corners of doors, holograms, spectrometers, separation of white light, etc. And daily life uses of interference are reflection of light from the film of oil floating on water, and when we pass light on a soap bubble, it reflects back and give a beautiful spectrum of different colors. Thank you and have a nice day.
Absolutely marvelous. You're on top of it. Meghna, let's see if you can answer this one. Bring it on. What is of the most uninteresting of all the periodic elements?
I don't know that. I give up. What is it?
Prawn.
I sincerely apologize to everyone who heard that. I know it would have been painful for your ears.
Hey, it wasn't that bad.
Yeah, it wasn't that bad because it was terrible.
Cut the crap. Let's invite our next participant. Code number M36. Be ready to witness another marvelous experiment. Code number M36 is not with us. Code number M39.
Hello, M36. Are we visible?
The call.
Hello. Hello, code M36.
Code number M39 is also not here. So our next participant is code number M40. Are you there?
Hello, excuse me.
Am I audible? Am I audible?
40, please respond to the call.
Am I audible?
उनकी वहाँ प्रॉब्लम है सब.
Am I audible? Hello, I am audible.
तुम्हारा कैमरा चेंज करके बोलो.
Hello,
Yes, you are.
my name is Sagar Bhardwaj and I am from M40. I am going to demonstrate a very well-known phenomena in our daily life, which is known as reflection. As we all know, as light travels through a given medium, it travels in a straight line. However, when light passes from one medium into a second medium, the light path bends. Reflection takes place there. The reflection occurs only at the boundary. Once the light has crossed the boundary between the two medium, it continues to travel in a straight line. For understanding this, we will do an experiment. We will take a jar and we will put the pencil inside this jar. We can see the diffraction of light. Because of this, this phenomena is occurring because the refraction of light, and we can also consider another experiment for this. We can see the arrow is in different direction, as it is in the air and it is in the medium. This phenomena is occurring because when an arrow is moved to a particular distance behind the glass, it looks like it reverses itself. When light passes from one medium to another medium, it can bend or refract. In the experiment that we have just completed, light traveled from the air, through the glass, through the water, and through back of the glass.
Recording in progress.
In this image, we can see the light all comes together is called the where the light rays come together. That point is known as focus point. But beyond the focus point, the image appears to reverse because the light rays that were bent pass each other, and light that was on the right side comes to left side, and the light which was in right side has come to left side. From this phenomena, we conclude that it is the occurrence of the diffraction. This bending by refraction makes it possible for us to have lenses, magnifying glass. The utility of this is for the prism, rainbows. Even our eyes depends upon this bending of light. Without refraction, we would not be able to focus light onto our retina. So reflection of light is very important phenomena for our daily life. Thank you.
Thank you, participants. We really appreciate your effort. Now, another call.
Excuse me.
Code number.
Hello, I'm code 36. Can I? Hello. Excuse me, am I audible?
Code number M04, Muninda Joshi. Are you there with us?
I'm code
yes,
36.
Am I visible?
Am I audible?
Yes, you are audible.
Hello, excuse me.
Read the code number.
Code number.
Code number M04. Start.
Yes.
Hello, am I audible? Hello.
Who is code number M04?
Hello, am I audible?
Yes, you are audible.
Moninda ji, what is your code?
My code is M04.
Please start the experiment.
Yeah, sure.
Before that, please rename yourself and don't disclose your school name. Join with your school code.
Can I take 5 minutes so that I can change my name and then I'll start with my experimental experiment?
We'll come back to you after one participant. Till then, code number M41. Please start.
Am I audible?
Yes, you are audible, sir.
Good morning, everyone. My name is Mridul Mehta. My code number is M41. Today, I am here to demonstrate some experiments on theme Wonders of Optics. So let's see. This is my first optical illusion. Wow, this is a wonderful experiment. Yeah, right. Tell me, how did the paper catch on fire? Okay, I will tell you. Take one plate and put some sanitizer on it, and now burn it with matchstick. We can see here that flame is not visible because in sanitizer ethanol is present and it burns with pale flame. It burns very cleanly because all the carbon tuned into CO2 gas. The gas emits thermal radiation which is less dense. So when I bring bring one piece of paper near it, it catches fire immediately. Paper is made up of wood and it has very ignition temperature. So let's move. This is my second optical. So this lens is called lenticular lenses. Lenticular lenses can be used to blur images along a single axis. The card has ridges that diffract light along the direction perpendicular to the ridge direction. So as a result, the card blurs the image along the single axis, along its short axis, but not its long axis. So the pencils on top get blurred to look as if they are behind the ones on the bottom. If you look closely, you can see the color of the pencil spread over the card. So let's move this. This is my third optical illusion. In the Mueller-Lyer illusion, the visual system would in the explanation detect the depth which are usually associated with 3D scenes and incorrectly decided it is a 3D drawing. Then the size is constantly mechanism mechanism would make us see an erroneous length of the object, which for a true perspective, drawing would be farther away. So let's move this. Just see. Wow, why did the arrows at the bottom change direction? Well, it is because of refraction of light. Refraction of light is the change in the direction of light when it passes from one medium to another medium. Here, air and water are the two media. So let's move. This is my fifth optical illusion. This is my fifth optical illusion. Our brain is confused by the difference in size between the large and the small radius. The makes the long side appear longer, and the long side long side makes the short side appear even shorter. But they are both the equal. See, this illusion is called gesture illusion. So thank you. Have a nice day.
Splendid. It is a sheer pleasure to see such innovative and interesting experiments.
Indeed it is. Now we'll come back to code number M04. We hope now you are ready.
Yes, I'm ready. And I hope you are visible and my PPT is also visible.
No, your presentation is not visible, ma'am. Now it's visible.
Is it now?
Yes,
okay, thank you. And sorry for the inconvenience caused. Okay. Yeah. We all have seen the beautiful rainbow in the sky after rain, which has 7 colors in it. And we refer to them as vapors. But have you ever thought that why is the color visible from a longer distance, even in fog and smoke? Is this the same reason that the sky in the morning is red in color? Somewhere, yes, with one more concept. During sunrise, the light rays coming from the sun have to travel a greater distance in Earth's atmosphere before reaching our eyes. In this journey, the wavelengths are able to the shorter wavelengths of light are scattered out and only longer wavelengths are able to reach our eyes. Therefore, the sun as well as the sky appear reddish in color. Beautiful, right? It is really surprising that these simple phenomena have signs in them. I always used to wonder that why the color of the sky is blue. Now I got the answer. The blue color of the sky has signs behind scattering it. Signs of scattering behind it. Gas particles in Earth's atmosphere scatter sunlight in all directions. Violet color scatters because of its appropriate wavelength, which is visible to us. Similarly, at the time of storms, and the dust particles are big enough to scatter the light of longer wavelength, so the sky appears red in color. These science talks are endless, and time is less. So now let me show you my projects. I have made 2 of them. Here I have used 4 LED bulbs of 4 different colors: red, yellow, blue, and green. I have attached a glue stick in front of them, and I have used their, I hope that's visible. Can you see it behind me? So there I've used 4 bulbs of the same color, red, yellow, green, and blue. And I have covered them with 4 layers of translucent sheets over the bulb so that I can show you the difference between the wavelength of lights. Hope you can see that red light has the longest wavelength and it deflects the least. That's why you can see it the brightest, and that is the same reason that why we paint the signals red in color. And the blue is and that is the reason that it has the longest wavelength and it deflects the least, and blue has the shortest wavelength. As it is far away from us, so as that is far away from us, the yellow light and red light is visible, whereas blue and green are getting scattered and somewhat becoming white. So now, if you see the danger sign or the color of the sky, blue or orange at the sunrise and sunset, so you would surely recall the signs behind it. Thank you.
Another marvelous experiment. I am truly startled by this one. Next in the queue, we have code number M42. Code number M42, are you there?
Yes, ma'am. My participant is looking for the permission to get enter in the meeting. Somehow she was being turned out.
Yeah, just a second, ma'am.
Thank you so much.
No problem, ma'am. Code number M42, I hope you are there. Please unmute yourself and start up with the experiment.
When I raise my right hand in the mirror, my eyes raise back the left hand. I wonder why it is so. When my friend poses for me to click a picture, I look at the 2mm lens and question how is it capable of taking pictures of this magnitude. Also, after putting my glasses on, I wonder how does everything look so much clearer than it looked before? Have these questions ever crossed your mind too? Have you ever experienced the same? If so, I'm here to feed your curiosity and enlighten you. Optics is the most fascinating as well as mind-boggling branch of physics. When we see water flowing in the middle of the highway, we question how can it ever be possible? But what we see is not the truth, but a deception, a mere trick our eyes are playing at. Hello everyone, I'm code number M42, and today we are going to uncover the mystery of science and explore the wonder of optics. Now my friends have very well explained all of the beautiful phenomena, but I am going to get you to the basics of the basics and demonstrate the laws of reflection as well as refraction. Now, let us see if we can actually bring all of our ray diagrams to life. Here, do you see this? Do you observe how it allows incidence on the mirror, it bounces back. This bouncing back of light is known as reflection. Now let's see if we can correlate what we have learned and what we have seen. Here, the ray that strikes the mirror is known as the incidence. The point at which it strikes is the point of incidence, and the ray that is being reflected back is the reflected ray. But what about the normal? We didn't see any normal here. That's because normal is just an imaginary line drawn mirror at the point of incidence. Now, if we measure angle at the norm, as well as we get that both of these, angle of incidence as well as angle of reflection, are equal. This is the first law of reflection. The second law of reflection is quite simple, and we have already seen it if you were paying attention. It states that the incident ray is normal, as well as the reflected ray, all lies in the same plane. Now, where do we actually use it? We use it every day, every hour, every second. When we are looking at ourselves in the mirror, when we go to a dentist appointment and he uses a magnifying glass to look at our mouth, or when we are driving cars and take a look at our rear view mirrors. But probably the most important application of reflection in daily life would be being able to see each other, our surroundings. Reflection is one of the main factors which enables us to see. One of the main factors. What about the other factors? Another factor which enables us to see each other is reflection of light. Let's see. Here and dipping these pencils in first alcohol and then water. We can see that these are being bent. The reason behind it is reflection of light, refraction of light, sorry. Now we are going to see here, we are going to observe the same phenomena with the help of a prism and see if we can actually infer something from this. When I point laser light at it, you can see that it is bending from its original. But we have always learned that light travels in a straight line, right? But we have also learned that when a certain obstacle comes in the path of light, it bends or deviates. This deviation of light, when passing from one medium to another medium, is known as refraction of light. Now, what are the different types of medium? We have mainly two types of medium. One is the optically denser medium, where speed of light is less. Another is optically rarer medium, where speed of light is more. Both of these terms are relative and not absolute. Let's have a look at the laws of reflection now, shall we? The first law of reflection is quite similar to the first law of reflection. It says that the incident ray, the normal, and the reflected ray all lie in the same plane. The second law of refraction says that the ratio of the sine of angle of incidence, code number M40.
Recording in progress.
Code number M43 is not there with us. Code number M47, are you ready with your experiment?
Yes. Can you hear me?
Code number M47, please respond to the call.
Okay. Good morning, myself Manjushi. My school code is M44, and today I am here with my wonderful project.
Next in the queue, we have code number M49.
Code number M49, are you there with us? Please respond.
Yes. Can you hear me?
Yes.
Okay. Good morning, all of you. My name is Anushka Yadav and my code is M49. So, as the topic is wonders of optics, today I'm also here with a wonder. And the topic is the laser light bending with a stream of water. First of all, we require a laser pointer. You can see this. A water bottle filled with water and a sink. Then we have to poke a hole on the side of the water bottle so that it can properly poke out smoothly. Then we have to point our laser inside it. I did it right here. And you will see that the stream of light will get turned with the stream of water. This is an example of total internal reflection, which occurs when the ray of light reflects which reflects while hitting the boundary of the medium. So, according to the physics perspective, there are two basic requirements for the total internal reflection to take place. First of all, the light should travel from the denser to the rarer medium. For example, from water to air, as I've taken it here. And secondly, most importantly, that the light should strike at the medium boundary and the angle of incidence should always be greater than critical angle. Critical angle is the angle of incidence which results in the refractive angle of 90 degrees. And for the water, this critical angle is 48.8 degrees. It gets changes as we change the medium we are working with, but here we are working with water, and so I'll show you how it works. Here we come. There is a hole in this water bottle, but as you can see that the water is not flowing out of it and the ray of light is straight through because the pressure of air here is greater than the pressure inside the water bottle. But as I will open the bottle's cap, the water started poking out because the pressure inside the water bottle increases. And you can see that the color of the water is red. Can you see the light here? And there is no light over here because the ray of light banded with the flow of water. This happens because water flow continuously over and over again with time. This was also very fascinating. But you know what? The coolest part about this complete experiment was that it is a perfect demonstration of how optic fibers work. The fibers we have in the cables which provide us internet. These are the long fibers of glass and plastic which can trap the light within them, like the waterfall did right now. You can see this. The light is bending with the flow. The same happens in the case of optic fibers too. And for another example, the total internal reflection also takes place in the case of mirage in deserts. You know very well. And for other example, we can also take that the sparkling of diamond is also responsible action of total internal reflection. So this was my complete experiment. Thank you.
Great enthusiastic. This was really genius.
Excuse me.
Let's keep going. Next in the queue, we have code number M50.
Excuse me.
Excuse me, M44 is available.
Yes, sir.
M44 is available.
Please repeat.
Board
Hello,
school code M44 is available.
Excuse me, school code M36 is also available.
Done.
Next in the queue, we have code number M44.
Yes.
I repeat, code number M44.
Yes, M44. Code number M44 is available here. Can you hear me? Can you hear me?
Yes, yes, you are audible.
Morning. Good morning, myself Ash Joshi of class 10th and my school code is M44 and today I am here with my project name as Invisibility Clock. You all have seen Harry Potter in which he used to take a cloak over him and become invisible. It was with the help of fiber, but it is with the help of lenses. And we can develop it in the defense sector also. So if we move further on, we have taken 4 convex lenses. We have taken convex lenses because they converge the rays at a focal point. Okay, we have taken 2 different types of focal length. Their ratios have been fixed, such as 3:1. So we have taken 2 convex lenses of focal length of 30 mm and 2 of 10 mm. Now we will move further for the practical of this project. Now, as you can see, we will go for the further explanation. Okay. As you can see, that Go is clearly seen. You all can easily see that Go is seen clearly. If as the rays of light converge at the focal point, the area between them are known as the invisibility area, and if you place any object there, it would not be seen. For example, if I place this pen between that invisibility area, this pen would not be visible to us. Let's confirm this, and This is how the pen becomes invisible and you can't see the pen easily. And this is the invisibility clock. Its uses has not been started yet, but we can develop this in the defense sector, and thank you.
Spectacular. These concepts seem so
Excuse
tough
me.
in theory, but seeing the practicals is a different feeling altogether.
School
I
code
absolutely
36
agree.
is available.
Next in the queue, we have code number 36.
Am I audible?
Yes, you are audible, sir.
Greetings to all present here. I'm code 36, and today I'll be demonstrating some experiments based on optical phenomena on interference, diffraction, as well as reflection. For diffraction, I have a setup here to basically explain how it works. First of all, diffraction is a phenomenon of light bending when it passes to a sharp or narrow edge if its wavelength is either equal to or smaller than it. Now, I'll switch off the lights to properly demonstrate the experiment. Here we have 3 slits, each with a gap of 1 millimeter variant. In case 1, I will use the slit with 1 millimeter wide gap. When laser is allowed to pass through the slit, a point is obtained on the screen. We can see that this point is wide, but in other cases, we can see the change. For example, in case 2, when I pass the laser again, and this time the slit is 1 millimeter wider. Yeah. Again, the point is obtained on the screen, but its width decreases. Now, similarly, in case 3, we have another setup. And here, the width of the slit is 2 millimeter wider than before. So we'll repeat the steps. And again, a point is obtained on the screen, but this time we can see that its width has gradually decreased and we get a point sharp object. Now, this decrease in width gradually appears due to angular fringe formula, that is lambda is equals to lambda d upon d, which is the gap between the 2 slits. We can also perform the same activity to these strands of wire. Here, between the wider gap of strands, when the laser point is allowed to pass, we get a point sharp ray on the screen. But when we pass it through a weight, let's say 1 millimeter here, we can observe a wider point. Now, similarly, this also has the same application of diffraction. Diffraction is now present in our day-to-day life, but we can always see it every day. For example, in sunset, the appearance of red sun. Now, actually, it is yellow, but it appears to be red because of diffraction. Now, we come here. There are also many holographic images. And for example, here is a light hologram, which is based on application of diffraction. Please wait a second. Here we have a video. You can clearly see a holographic image in the middle. Now, basically what we have done is placed the hologram prism made up of 4 sides and placed it on 4 videos continued played. And when this is placed on this video, we can see that a holographic image is formed in between due to diffraction. Now, not only in diffraction, but also in separation of white light and also in peacock feathers. Originally, the color of peacock feathers is brown. But here, as you can see, light is falling on it. It appears to be what we call multicolored peacock feathers. Now, for separation of white light, I would like to switch off the lights again and demonstrate. Here we have a CD, and when we display light on it, we can clearly see the 7 color spectrum. This pattern can also be obtained on the screen. Now there is also a chart basically representing why a prism is formed on the screen. This is because when the incident light falls on the CD, the first order forms the picture as we know it, but in reverse order. And in the zero order point where the prism was basically formed in center, another order is formed where picture as we know it is in order of sequence. Apart from this, reflection is present in our day-to-day life. And based on it, we have created an infinite well. Here is an experiment. Here we have tested light reflecting on the glass, which gives us with an illusion of infinite well. The basic principle here is multiple reflection. That's why it looks like it never ends. Thank you.
Absolutely phenomenal.
Meghna, I've gotten another question for you.
I hope it is not as lame as the last one.
Yeah, whatever, it's not.
Really? So let's go. I'm up for it.
Okay, so the question is, what number do nickel and neon make when they combine?
Okay, let me think. Is it 9?
Yes. Symbol of nickel is Ni and symbol of neon is Ne. And when they combine, they make a 9. Pretty impressive, Meghna.
Well, I know. I will be the greatest scientist in the history of mankind.
Well, it wasn't that impressive. Anyways, moving on to our next participant, code number N50. Code number M50 is not with us. Code number M55, are you ready with your experiment?
Yes. Is my screen visible?
Yes.
Namaskar. Myself, Bhavika Dhamija, and my school code is 55. My project is a sunlight collector in which I'm using optical fiber to collect sunlight from the roof and send it to the required aid. This is an image of an optical fiber where one end of the optical fiber is exposed to sunlight and has planar convex lens, and the other end is in the dark box. Optical fiber works on the principle of total internal deflection. When angle of incidence exceeds the critical angle, the light from the denser medium is reflected in the medium instead of refracting to the rarer medium. By using this phenomenon of total internal reflection, light superimposed with the data signals can be sent to large distances within fraction of time and without even using the data. Data on internet sent with the help of optical fiber. BharatNet is one of the flagship program of Government of India, which intends to connect 250,000 village panchayat with high-speed internet connectivity of 1 GB with the help of optical fiber. Optical fiber also find their use in medical investigation. They can also be used to measure temperature and pressure, in photometric sensors to measure the blood flow of the heart, and as reflecting meters to determine the reflected indices of the liquid. Optical fiber consists of a central core, a cladding, and outer protective jacket. The light is made to be incident at the central core at an angle greater than the critical angle. So instead of reflecting to the cladding, it is totally reflected in the central core and sent to another end of the, and light is sent to the other end of the optical fiber. Now I'll show you my experiment. This is my sunlight collector. This is the other end of the optical fibers which will be exposed to sunlight. We will be having a convex lens here to converge the sunlight beams. And sunlight is not always available at an angle greater than critical angle. So this planar convex lens will make sure that the incident ray is always greater than the critical angle. Here I'll be using a laser light to demonstrate the object. This is the other side of the optical fiber, and this is the dark room. When I incident the light ray, it is It is at an angle greater than it is incident at an angle greater than critical for only some of the optical fiber. So you can see that light reaches at the end for only some of the optical fiber, not all. Now I'll share some calculations based on my research. If we assume that each household has 5 tube lights operating 8 as a day, it costs around 18 rupees to a user. According to the data by Indian Statistical Organization, there are 300 cities with over 1 lakh population in India. Assuming in one city there is 2 schools, 1 hospital, 1 office, 1 mall and 1 industry, we can save around 16 lakh 20,000 rupees per day using this sunlight collector. This sunlight collector can be of great use. They can illuminate high-rise apartments and underground observatories and mining sites. We can also send sunlight underground to grow plants in polar areas where sunlight is not available every time and facilitate solar cooking in the kitchen. Thank you.
Definitely astounding. You are on top of it.
Yes. Next in the queue, we have code number M57. Be ready to see another experiment.
Excuse me, please. I am code M52 and I am also present.
Code number M57.
Please respond. The final call for code number M57. We'll come back to you later. Moving on to the code number 59. Code number M59, are you ready with your experiment? So code number M57 has joined us. Please show your experiment. Ma'am, please unmute yourself. Yes.
Am I audible and visible?
Yes, you are audible.
Let me share my screen. A very good morning, respected jury, teachers, and all my dear friends. I, code number M57, would like to demonstrate my experiment on fibers. First, let's know about what's optics. Optics.
Code number M57, your screen is...
Is it done now?
Yes.
A very good morning, respected jury, teachers, and all my dear friends. The topic for today is optics. Optics is the branch of science that deals with the study of sight and light. Optics has helped us in many ways, through microscope, telescope, camera, lasers, optical fibers, and surgical instruments. I would like to demonstrate my experiment on optical fibers.
let's know more about optical fibers. Sounds and pictures are encoded in pulse of laser light, which are then sent to an optical fiber. Optical fiber is a flexible and transparent fiber of size of a human hair that is used to transmit data through light. Having known this, let's get into the experiment. My experiment is based on the principle of total internal reflection of light. The aim of my experiment is to study the working of an optical fiber. The material required for my experiment is totally co-sufficient. It requires a water bottle, foil paper, water, and laser. The concept behind my project is sounds and pictures are encoded in pulses of laser light, which are then sent to an optical fiber. All the light reflects off the inside of fiber, so none of it escapes. As a result, the signal remains strong for even long distances. More than one signal can travel through an optical fiber at the same time if different wavelengths of light are used. Optical fibers are used to carry telephone, TV cables, and internet signals. For the procedure, I've covered my water bottle with foil paper, except for the bottle. Fill the bottle with water, and now pass a laser through the bottle at an angle. When we pour water, we see that the light comes out along with water. Let's see the live demonstration. You can see how light passed through the water without any loss in transmission. So we concluded that the water bottle represents optical fiber. The laser represents information, and this experiment shows how efficiently all the information gets transmitted through an optical fiber and no light escapes. Now we come on utility. Utility of this experiment is that we use Wi-Fi and 4G networks in every day. It is based on this principle. Optical fibers are used to carry telephone, TV cable, and internet signals. Optical fibers are widely used in medical field to diagnose many ailments. For example, in upper gastrointestinal endoscopy, an endoscope is inserted through esophagus into the stomach of the patient, and the light passes through it. It also helps in 5G, the new technology which is to be developed. With this, I end my experiment. Thank you.
Great enthusiasm, participant. Moving on, next in the queue, we have code number M59. But before that, I would like to request code number M57 to stop the screen share. Okay. Now, code number M59, are you there? Code number M59 is not there with us. Now, all the codes that are left to show their presentation, please raise your hands.
Code number M52, you can show your presentation now.
Good morning to one and all present today. I am Devansh Arora, code number M52. First of all, I would like to thank the organizers and the judges for giving me this opportunity. My today's experiment is very simple and anybody can do it at home. So let's start with it. Here you can see a glass which is filled with tiny little balls of water. Now, assuming that I am telling you the truth, there is something below the glass, not a material, but some drawing. You can see an arrow behind the glass. Something is below the glass as well, but it is not observable at the moment. But when I pour some water in it, the arrow becomes visible. Now, how and why the arrow becomes visible? We will come to that question in a second. But the second part of my experiment, give me just a second, please. I hope you can see this arrow. As soon as a glass of water comes in front of it, the arrow inverts its direction. Now how and why? That's the question. For explaining this, I would like to share my screen. Yeah, so here you can see some circles. They are actually representing those water balls which I showed you in the first experiment. As soon as I turn the light on, you can see that light does not travel straight. It bends when it hits a circle, or in this case, a water ball. If there are multiple lights, as in our case, all the lights deflect from their path and we are not able to see what is underneath the glass. But if I turn the outer medium to water as well, this is the situation when I added the water to the glass. Then you can see the outer medium and the inner medium are the same. This allows the refractive indices of the outer medium and the inner medium becomes the same, and that is why the light is able to pass straight through it. This phenomenon of bending of light is what we call refraction. For the second experiment, this I am showing you the top of the glass. If light is passed through it, you can see that the light, all light converges at a point. The light from the top bends and ends up coming at the bottom. The light from the bottom again bends up and goes to the top. That is why the top point of the arrow makes an image downwards and the bottom point of an arrow makes an image upwards, due to which if this arrow was straight, then we would have seen the inverted image of the arrow. In our case, it was what we call lateral inversion. So now, where do we use this? Now, this same phenomena is used in glasses. We all not many people wear glasses. So we have such lenses. This is a biconvex lens. We have such lenses in the glasses which bend the light so that the people who are not able to see clearly far off objects, their retina, the light focuses on their retina and they are able to see that clearly. That's all for the day from my side. Thank you and have a great day.
Mesmerizingly and performed. This was really informative. Participant, I want to confirm your code. Is it 50 or 52? Code number M52. Please confirm your code. We repeat.
I have just
Please
presented.
verify your code. Is it 52?
Yeah, I am code 52 and I have just presented.
Okay. Now, 7, you are recognized. Please show your experiment. Code number M47, you are recognized. Please show your experiment. Okay.
Morning everyone. Myself Nancy Hansal, code number M47. Today my project is about the solar bulb. Solar bulb which are prepared for the people who don't have electricity in their houses. For them, I've prepared the solar bulb. How does it work? I've taken two bottles here. As you can see, there are two bottles in which I filled with water and a little bit of bleach. It will work with sunlight. If sunlight passes through these bottles, so through reflection, through reflection, the water will spread the light inside the hut. So there will be light inside the hut without any electricity. Simply through bottles, through recycled bottles. This way of making solar bulb is really cheap and really utilized. We can easily use it and we can fix it in the top of the hut. And for the other thing, as for the night, we can fix small solar panels along with the bottles. So the whole day the solar panels will charge up with the solar light, and at night they will provide light to the hut. So the people who don't have electricity can use this, and this is very cheap and utilized. A really fixed and properly made sunlight bottle or solar bulb can last for 5 years. So it is really useful for those people who don't have electricity in their houses. So how this is works, like we can take it as a sunlight, and sunlight through the water bottle will spread the light inside the hut. And as for the solar panels, we can attach a switch or battery to solar panels, and it will charge the solar panels and it will provide light to the hut. Thank you.
Really innovative and interesting experiment. Now I would like to call code number M59. Code number M13, are you there with us? The final call for code number 13, 39, 43 and 59. I repeat, the code number 13, 39, 43 and 59. If any one of you is here, so please display your experiment. Anyone who is left to show the experiment, kindly raise your hand. Code number M59, are you there? I repeat, code number M59.
Yes.
Code number M59.
Yes, I'm here.
Okay. Code number M59, please switch on your camera.
Okay. Ma'am, should I start?
Please start your
Sure. 1 second, please.
One second. Good morning. I'm Tejaswa Jadhav, class 12. Today I'm going to present experiment on refraction through a prism and finding its angle of deviation. So did you know that the scientists today are very close to successfully inventing an invisibility cloak? If you think this is a magic, you are wrong. The aim of these scientists is to make a fabric that will hide object completely, at least in the visible side. This is based on a very basic scientific principle, and that is the principle of refraction. According to this, when a light travels from one medium to another, it changes its direction. So I'm going to perform an experiment on. So what is a prism? Prism is a three-dimensional solid object in which the
Your camera isn't placed properly, code number M59.
Actually, I'm going to perform it, so I'm aligning it. Sorry.
Okay.
Wait, please. 1 second. One second, please. So the prism is a three-dimensional object which is two ends are identical. It is the combination of flat faces, identical bases, and equal cross section. The faces of the prism are parallelogram and rectangle without the bases. Now, if we take a glass prism like here, you can see that it has two triangular bases and three rectangular lateral surfaces inclined at an angle. This angle is called the angle of prism. So let's look at the top view of a triangular prism with a ray of light emitting it. So here you can see that the light is bending toward the normal. This is because, as per Snell's law, light traveling from a rare medium to a denser medium bends toward the normal and vice versa. Glass is denser than the air, and thus when a ray of light falls on the surface of the prism, it's bent toward the normal. So now we can also find the angle of deviation from it. To find the angle of deviation from it, if we extend the incident ray forward and emergent ray backward, as we can see in the diagram, the angle of the point where these both connect is the angle of deviation. Here you can see that the D is the angle of deviation. That's how you can find both angle of deviation and diffraction through a prism. So prism uses a reflection to form a spectrum of colors from an incident beam of light. Refraction is also responsible for the ability of cornea and lens of the eye to form a real image on retina. Spectacles are worn by people with defect vision use refraction for provide correct vision. Refraction is also responsible for formation of mirage and other optical illusion. When you drink glass, you can see when you put a straw in, it's bent, but really it's when the light goes through a water and as it bounces from the straw to your eye. Refraction is also used in working of telescopes, microscopes, peepholes of house doors and cameras, movie projector, magnifying glasses, etc. If we keep some colorful fishes in the aquarium, we can also enjoy their interesting movement. The light from the fish coming to the water at first falls on the glass of the light reaches our eyes, therefore it is also a contribution of refraction.
Are you done with the experiment?
Yes.
M59, are you done with your experiment?
Yes, I'm done with my experiment.
Thank you so much for your performance.
My
It was
pleasure.
stupendous. Now, is there anyone in the meeting who will do the experiment? If so, then please raise your hand. Is there anyone in the meeting who is left to show the experiment? This is the final call. You can raise your hands. So, with this, we have come to the end of today's event. Now, we, on the behalf of MGPS fraternity, would like to extend our warm gratitude to all the vivacious participants for their active participation and making this event a grand success. But remember, the journey never ends. There is always going to be growth, improvement, and adversity. Continue to grow, continue to rise, and live in the present. Keep on nourishing your mind and take care of your spirit. It's time to celebrate all that we have and prepare ourselves for everything that is to become. It is time to celebrate science. Thank you all for being such a wonderful audience.
Recording